yeah, let's see. In terms of the review material, okay, it's right here. All right, so I think I didn't make yeah, let me click this. So quiz one is super simple that I didn't really make the file available. But yeah, you guys for the ones that are a little bit more complicated, let's say quiz two. So the quiz two, this icon is basically the just a clickable, okay, downloadable PDF file that's attached to this note. Okay, so you can download it and also just for whatever code that you are unsure, just copy it down and paste in your Python interface. Okay. And the quiz three is what I just shared. Okay, so indeed we have classes. So what I can say here, I think in your own way to put down the returned statements of true and false, it's gonna be fine. Okay, as long as it's bug free. But here my comment is that I have seen a few submissions. You can just do it in one line. Okay, just the Boolean operation. Okay, just comparison that would be sufficient. So whatever there's one like an underline for the blank, it should be able to it can be completed by one line. Similar to this one. Okay, this one. If you are not sure, then go back to the live coding of section 9. Okay, we are saying you have the amount of owned, right? So that's basically the principle, and you wanted to reduce, but then you wanted to stop reducing when it's about to cross the one half of the original loan amount. So that's possibly something common, but of course we're gonna elaborate on Monday. So for this one, okay, also make sure to think about so every one of the functions, okay, methods, they can be completed by one line. But here I'm just making a little bit more spaces for you to write things. But think about putting them down in one line, and of course make sure um, that you let's say for DQ, okay, you want to manipulate the data and return uh, an entry at the same time. Here for NQ, you are manipulating the data. Okay, just try to make sure that the things can be implemented nicely. And also go back to the live coding notebook to copy it down and look at the display. Okay, we have discussed this in our live coding, but think about think about what it means when you say print an object. Okay, and print an object is basically defined by the str method. Okay, so that str method is usually right here. Okay, so that's the way that you define. Okay, if you don't define it, then it will not be specified. But then it's really up to what kind of str representation of your object that you want. Okay. That's sort of something we are trying to emphasize in this quiz. All right, and of course, we can discuss this once I see all your work. But yeah, at the top, okay, this icon here is basically a downloadable PDF file. All right, so that you can copy down the code from there. Okay, where were we? We were talking about so NumPy. Okay, so make sure to import always. Okay, this NumPy is another package that's written for like matrix computations. So that's efficient matrix computations and linear algebra. So that's the NumPy package, and NP here is the nickname. Just it's a shorthand. Okay, so that you don't really have to type NumPy every time for that class. And if you think about the way that you are doing the conversion, it's essentially a Python list that you actually convert to a NumPy list, NumPy array. Okay, so it's called an array. It's always like this. So just remember this kind of data structure is it's a list of lists, right? The sublist here is 1, 2, 3, and then 4, 5, 6, and then 7, 8, 9. Right? Mm, so we also mentioned that, okay, if you have A plus B, now you have two NumPy arrays you're adding. Okay, so earlier when you have lists, okay, when you're adding, you are just putting the elements together. But now when you are doing the addition in NumPy, you are doing element-wise addition. That's what we have mentioned earlier, entry-wise or element-wise. So, okay, so that's roughly speaking the review from last time. And of course, here the last output here is the type of A. A is now a NumPy array, so it's the type is NumPy dot ND array. So that's the type of your object. All right, what else? So here we have two different we have two different kind of lists. Okay, so J and K. So J is actually one list of three singleton lists. Okay, so you can think about this like three different rows. Okay, so one is in the first row, two is in the second row, and three is in the third row. So it's exactly when you get to the NumPy arrays conversion. So essentially, the printout is going to be exactly like this. So 1, 2, 3 is different sublists. So that will be represented as three different rows. And then for one list, it's going to be one row. And then for the next one, it's going to be the second row and then the third row. So it's sort of like creating with respect to different rows comparing to different columns. So that's what we are seeing right here in terms of especially for the print of the NumPy array. So once again, so when you're printing an object, okay, in a particular class, then this way of printing is defined in terms of NumPy that they're getting rid of the commas, okay, throughout the list, right? So this is pretty important, and they sort of like do this in purpose so that for one array it's going to be a row, and then if you have multiples, then you will get to different dimensions. Firstly, it's row, and then it's going to have different excuse me. Firstly, you have a row changing the column index, and then you're going to change the row index. And finally, now it's going to be changing the matrix index. Then you have different matrices that you are putting from top to bottom. So that's kind of the logic here. So now, a very important difference. So Python list, are we able to compute a component-wise division out of two lists? Actually, it cannot be done in a direct way in Python, unfortunately. So if you're looking at what we are doing right here, this is basically saying, okay, I have distances as a list. I have times as a list. I want to calculate, let's say, the distance over time, which is the speed, right? I want to also get a list, but now, unfortunately, we would have to do loops. So this cell is basically saying now we do the ith index of the distance list, and then over the ith element of my times list, and then I'm gonna do it element by element, just constructing a new list of speeds by appending. Okay, so unfortunately, this is doing a loop is what you are able to do, and if you do in Python directly distance over time using the division, it's not going to be well defined. So there's going to be an error. So these are certain things that you can play on your side of the notebook. But of course, there's going to be a more efficient loop, which is what we have seen from before, which is what's called the basically one-liner. Okay, so what we can do here is using what's called the zip function. So this is also something really common. So the zip function basically just you take two iterable objects, okay, two lists, or tuples, okay, and then you use zip to put them in one iterate of pairs or tuples. So it's taking two iterables into one iterable of tuples or pairs. And the data structure here is really special. We're gonna run this cell in a bit. But then what it does is that, okay, it just form the list of pairs. Okay. So now every element in your pairs is gonna be distance time pair, and it's gonna be a new list. And then what you can do here is do list comprehension. So then this line, you are computing the speeds by doing for each dt, okay, each pair in my list of pairs, I'm just gonna do d by t. Okay, so that's also a loop. It's just going to be a little bit more efficient than your kind of like naive for loop, right? So now as we have a few commented things out of the cell. So let's quickly run it, okay, to see what's actually going on. So let me also try to make sure that my Python is executed so I can do it. Okay, so it's fine. It's can be done without harm. So these ones are kind of trivial. So I need to get my distance and times, and then here, okay. So I want to get the pairs. Okay, so firstly, let me get the type of my zip. So every time it's going to display one output, which is why we are trying to comment things. Okay, so now the type of this pairs is a zip, so which is really special. There are indeed many different kinds of types of objects. Okay, so this is a zip, and then if we can also print the it's going to be control. It's going to be indeed. Okay, so when you zip, okay, it's going to be the list of pairs. So, but here notice the type of pairs is zip, right? So you want to convert your list to iterate. So indeed, this is a list conversion. Okay, so I have, you can do it by zip of list one, list two, and then embed it into list. List function. Okay, so that will give you indeed a list, which is what we will see right here, and then we iterate. Um, so let's try printing the pairs and see what we can get. So you see, this is indeed a little bit weird in the sense that, okay, if I directly print pair, it's going to be what's called zip object that this is actually an address in the memory, okay, in your computer. So in order to display it, you would have to convert it to a list. But then in terms of the computation, you don't really need that. You just need, okay, you just need to iterate. And of course, I want to print it. So, so then that's done, right? So as expected, we are doing like components-wide division. But now just realize, okay, so pairs is iterable, but it's not a list and it's not printable. Okay, so that's really special here. And then now what about the current list of pairs? Now it's an empty list. Okay, so this is also really special about zip in the sense that zip is a way that you are sort of like storing the things in the memory. However, basically, once you iterate the elements, then the elements are going to be removed out of the zip. So at the end, when you iterate everything out of the pairs, then the pairs becomes empty. So the list of pairs is going to be an empty list. Okay, so this is something really special about the zip that we want to sort of like emphasize. Okay, so uh, once So once iterated, elements are removed, okay, from the zip data type, right? But of course, this is the way. So you can sort of like just form pairs and tuples, okay, for your own iterative purpose. So you can do one-liner, okay, list comprehension. Right. So now if you want to do high dimensional lists, it's doable, but still it's going to be a loop. So let's say you have A as, let's say it's sort of like a matrix. Okay, we have the first row as 23, 41. The second row is negative 1, 2. The first row B is 2, 94. The second row is 3, 4, 3, 8. So here, if you want to compute like the component-wise multiplication, so it has to be like a double loop. So I going from 0 to 1 and j going from 0 to 1, meaning you have the zeros and i's sublists, and every sublist has 0 and 1 index. Okay, so that's sort of unfortunate. This is again a loop. But then here, notice that we have L3. What is L3? L3 is like a pre-location of the data, okay? Because you want to get sort of like a 2 by 2 matrix, okay? So you do need to sort of pre-locate the data structure so that it's going to be in like an empty 2 by 2 list, and then you compute the element-wise elements. So this is sort of unfortunate. But in NumPy, they just do it within their within their class, so that basically every time you predetermine the data dimension, and then everything is just follows. So again, the loop. Okay, so this is a pre-allocation. It's 2L, pre-allocation of memory. Okay, so and the index, and this is again the loop. So so yeah, make sure to play with the output of the cells. Okay, but here when you talk about L301, what does it mean? It means you are looking at the list 0, okay, and the one element in your sublist 0. Okay, so now it's going to be the location of so that's my list 0, and that's my element 1. Okay, so that's going to be that one. All right, and here you want to compute this out of the multiplication of these two elements. Okay, so that's where you get this negative 164. Okay, so negative 41 times 94, right? So pretty standard. So there isn't really a lot to say about this these code cells, but they just execute and think about what it does. And of course, this line is converting to list to NP array, NumPy array. All right. And here, this cell of speeds equals to distance. Distance is over times. This arrow is going to be displayed above, so so we don't really have to execute on our end, but just realize that for Python lists, okay, you cannot really do direct division. But but NumPy here is to help you with this kind of component-wise multiplication. Okay, so let me highlight. So this unsupported operation. Okay, for the type of lists. So now, what can you do? So we can make an NumPy array D, which is converting from distances to NumPy. and converting times to as a t. And then now speeds, I can do direct division. So this is going to be component wise. And the result is going to be another NumPy array. All right. So now, so if you print it directly, okay, so that element is going to be this array of this of lists of numbers, all right, which is still NumPy array. And of course, if you print it, it's going to remove these array and brackets and the commas, all right. And multiplication can be done also element wise, okay, component wise. Multiplication. So not only you can avoid loops, but also it's going to be much faster, okay, than list comprehensions. So that's the strength of kind of like a MATLAB and or this kind of NumPy programs, in the sense that they sort of optimize this kind of linear algebraic operations. So that's what they mean by saying, okay, I need to vectorize the data. So meaning that, okay, I'm going to put the data in terms of matrices, or like more generally tensors, so that the computations can be efficient. But then it's going to be relying on either MATLAB kind of format for C++, or this kind of a NumPy kind of package. Okay, so for Python. All right. So what are the operations that can be done? So we can determine the size, shape. Shape is really up to the data structure of your like say array, matrix, or tensor. And then it also can determine the memory consumption, the data types. Okay. And we can get and just extract and change, okay, the individual element. And this is slicing, okay, that's we can also do. So we're going to also see them really quickly. But they are not really different from the lists. And changing the shape, this is very important. So sometimes you are given a list, you want to convert it to, let's say, a matrix or a tensor. It can be done as long as your dimension is compatible. And sometimes you have data structure like a matrix and the tensor. You want to flatten it, okay, to a vector. Okay, so that will be easier for later computations. So that's also can be done. Okay, so this is reshape. So that's the reshape as a function, okay, or a method that we can utilize. So this is very important. Combining multiple arrays into one, splitting one array into many. So that's also what you can do with NumPy. All right. Okay. So this cell. So what does it do? So basically, we are generating. We're generating a range. Okay, so this is basically sort of like the range, but now it's going to be a range. Basically, we're getting the array. Okay, on that range. So this is what that a means. So this is just the array from 1 to 9. Okay, so stopping at 10. Okay, so this is 1 through 9. So which is what? Which is like 9 elements. So indeed, this one you can reshape it to 3 by 3. So that's doable because the dimension is compatible. And then here, if you're looking at this 1 through 13, it's actually from 1 to 12. Okay, so the integer values, and that can be reshaped in terms of 4 by 3. If the dimensions are not compatible, then you cannot do it. Okay, so let's quickly look at the cell, because the cell I edited a little bit, but it doesn't reflect in our code. So in our note. So we are. So let's execute that. Well, it doesn't really help because okay. So okay, we have one so a range from 1 through 10. Okay, so That's actually 1 through 9. I can reshape to 3 by 3. So now it's a 3-row, 3-column matrix. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is like the natural way that you sort of like making it a matrix. So basically it's like, okay, so for the first list, I'm gonna fill it up. And then I'm gonna do the second list, and then I'm gonna do the third list. Okay, so that's the logic. So it's really straightforward. But you cannot really do it for a different dimension. So it will be you cannot reshape an array of size 9 to shape a 4 by 3. Okay. So similarly, if you are playing with from let's say 1 to 25, and let's say if you want to try convert it to 4 by 3, are you able to do it? And in fact, again, no. Okay. So 24, you need to be a total dimension of 24 that you convert. So that you cannot do, but you can do it into like a tensor. So this is why we have the list, we have the reshape of 4 by 3 by 2. So this is like a 3D array. Okay, so that can be done. Okay, so now you see, so what it means is that okay, I have four lists. Every one of the 4 lists is 3 by 2. So which is why here I'm seeing, okay, this is my first part, 3 by 2. Okay, well, 1, 2, 3, 4 by 1 through 6. And then the second one is also 3 by 2. The third one is also 3 by 2. Fourth one is also 3 by 2. Okay, so that's a list of matrices. So that's really natural. And now, what can we do when we want to vectorize it back? Okay, to get it to 1 dimension, so that it's eventually a vector. So there are multiple ways. One way is that okay, I still use reshape, but I reshape to get the argument of -1. So what it means is it's just when you see -1 there in the input, it just means I want to flatten it. Okay, I want to get it to a complete vector. So once you do that, you're just gonna get the original 1-dimensional thing back. And that's also can be done. So this is what they call by flattening. Okay, so making it a 1-dimensional object. And you can also do revel. So it's really common. Okay, so especially let's say you have 2-dimensional data like an image. Okay, so it has a row, so like the number of rows and the number of columns and the number, and there's a dimension of like a color. Okay, so it's possibly A by B by 3. So in that sense, it's sort of like a tensor, and you want to vectorize it before you feed into a machine learning model. So that operation that you're going to do is this revel or reshape -1. So either way. Right. So that's one of the things that we sort of need to emphasize a little bit. But yeah, well, I would say that's pretty much it. Except in multivariate calculus, for different data structure, for when you take the gradient, okay, or when you take the partial derivatives, there are different data structures that you need to worry about, because matrices, they have different kind of matrix multiplications. Okay, so it's a little bit more complicated than vector and vector dot product. So yeah.
Shaper, can I choose which row or column I want to use?
So usually, so this is a very good question. Usually there will be freedom of choice, but in machine learning, we would recommend you not to do really special choices. You want to do the conventional way. So just do the way traditionally people would do. Otherwise, things may change really dramatically in terms of inner calculations. So what I'm talking about, what I'm saying here is that it's indeed about, let's say, a neural network. You have a bunch of layers that you are passing through. So it's going to be a composition. There will be a chain rule involved in terms of computing gradients. So now different data structure of the input will give you different kinds of computations inside that kind of chain rule procedure, which is why, commonly speaking, when you say you want to reshape, just get the tell them about your dimension, and then just do the conventional way of reshaping. And then when you flatten, then you will get the original data back. All right. Otherwise, it will be kind of messy stuff. Okay. So yeah. So what you're asking here is kind of really natural. So where is it? I want that. I want the data structure of my 24 dimensional data, right? So this is saying, okay, I fill up the first matrix and then the second and the third and the fourth. Right? So you can say, okay, why not I fill up by column? So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and then 7, 8, 9. Well, it's not really difficult by doing the programming part, but it's just everything afterwards would need to be adjusted, which is just going to be a pain, which is the reason why we try to do the conventional way. Yeah, it's just not worth it. So, yeah. Right, very good question. But when they ask you, okay, how do you vectorize? How do you make the data into vectors? So that's that. Okay, reshaping and the flattening. Really common. Okay, so you're gonna if you ever get into the deeper sequence of the machine learning program, so you will see that more often in machine learning tasks. And then what else? So NumPy array operations. Of course, so we just needed to be, so NumPy arrays just needed to be homogeneous, but it can be, okay, it can be strings. Okay, so the data type can be strings, it just need to be the same everywhere. It can be Boolean, okay? So for instance, if you see this, what does it mean? So let's see. I have a NumPy array of 2, 3, 5, all the way to like 57, a bunch of numbers. So if I do a less than 15, what does it mean? It returns an NumPy array that has true or false statements. Okay, for every element, if the element originally were less than 15, it's going to be a true. For all the numbers that are large, it's going to be a false. So which is exactly what you see right here. Okay, so this is I'm gonna name it as B. So now I print B is gonna be okay, less than 15, true, true, true for these ones, and then everywhere else is gonna be a false. Okay, so later in the live coding, they say, okay, form a 3 by 3 NumPy array of truths of true. Okay, so then what you do here, one way is that okay, I construct a 9-dimensional true false array, and then I convert it to a NumPy. Or what I can do here is I just get a bunch of numbers and then make this kind of Boolean operation so that I convert it to a NumPy array of true or false. All right, so and also try to check the type. The type is just gonna be the same thing from before. It's gonna be NumPy and the array, but it's now using true or false. So yeah, let's quickly look at the things and then we put it to an end. So here we're saying, okay, this is sort of like slicing. Okay, so for all the entries that have a less than 15, I'm gonna get the elements. So I only have. So let me run this, and let me run this. 2, 3, 5, 5, 4. Okay. So here I have 2, 3, 5, 5, 4 right there. So extracting the elements that you want, sort of like slicing. Yeah, scalar multiplication. So remember, if you will have an original Python list, then 3 times that is actually a repetition of 3 times. Okay, but now everything is component wise. So think about, yeah, just let's put it to an end for today, and make sure to play with the cells and think about what they actually do. But essentially, they are really straightforward once you understand the things. So yeah, let me stop recording, and yeah, I'll see you guys on Monday. Make sure to come and get your quiz back. Okay.